tornado roared through Tinker Air Force Base, Oklahoma, causing considerable damage, a few injuries, but no fatalities. However, the destruction could have been much worse, for it was 5 days earlier, on the 20th of March, another tornado had rolled through Tinker. And there were two forecasters there, Captain Robert C. Miller and Major Ernest Fawbush, experienced that first one. They wondered, is it possible that we could possibly have predicted for this? And they went to the charts and they pored over the science and they looked and analyzed and came up with a method to help predict the occurrence of a tornado. And so 5 days later, they were given the chance, and they sat down there, and the base commander, the general in charge, sat across the desk from them, and they briefed them about the conditions and the possibility of more severe weather. And he asked them, he says, "Are you going to issue a tornado warning?" He says, "Sir, that's never been done before. Nobody's ever issued a tornado warning." And he said, "Well, you're just about to make precedent then, aren't you?" To which they did, and it cost the base $6 million, but that was $4 million less than the previous tornado. So you could say right there, that very first forecast saved the government then around $4 million, which, you know, you could do the math, it's probably in the hundreds of millions of dollars today equivalent. So that forecast, in fact, helped basically revolutionized the civilian weather service. For at that time, the Weather Bureau had a policy against issuing tornado warnings, mainly because they didn't want to panic the public, and the science was so young, they didn't really feel they could do it. And it took a couple of Air Force guys with enough guts to say, no, we can do this. And so they helped revolutionize the landscape and bring the civilian weather forecasting capability to what we see today now with our profuse number of warnings and advisories. Fast forward again, this is fall of 1944. You may recall Operation Deny Flight. This was the NATO enforcement of the no-fly zone of Bosnia and Herzegovina. You've all probably heard of Scott O'Grady, the shoot down, the rescue, that whole thing. That was a part of that Operation Deny Flight. Well, the 31st OSW, the weather flight located with the wing there, were responsible for providing wide-ranging support to more than 90 aircraft operating from the single runway airfield. So on this particular occasion, several lines of F-15Es, similar aircraft to what you see out here, they're F-15s, whose purpose was for enforcing this no-fly zone. On this particular day, the winds were blowing particularly strong out of one direction along the runway. And these missions were set to go off, to take off during the day, but they were going to land at night. And the problem was, when they are landing at nights, the runway restrictions required them land from a certain direction, and that direction happened to be a tailwind direction. So those aircraft would have to land with a tailwind. Well, the problem was these military aircraft, they're going up fully armed because they don't know what kind of hostility they were going to find, or if they're going to find bad guys flying where they weren't, and they'd have to shoot them down. So they're going up armed, but by and large returning armed as well. And when you have an aircraft landing heavy with explosives on their wings, you can't do that with the tailwind. And so this particular mission, they were anticipating that they would not be able to land at the airfield. In fact, this happened frequently where the tailwinds would exceed their minimums. The aircraft would have to divert to another base 240 miles away. And when they did that, they had to take a whole bunch of personnel from the air base and basically fly or truck them over to this other airfield so that they could recover the aircraft and get them turned around. So that's the impact there that weather was having on them. And in this particular case, the winds were strong. They thought they were going to have to do that, but the forecasters saw conditions such that the winds were going to die down. They said, well, we know right now it's bad, but it's going to get better, and you'll be able to land here. And they stuck to their guns, and they told the commander, no, sir, you can stay here. Don't worry about it. The winds are going to die down. And that's, in fact, what happened. And the next day, the base commanders looked at the weather guy and said, you know, you just saved us about $50,000 or more in expenses in having to move all these people to another location. And so it's a small example of how much a weather guy can impact an operation. Speaking of winds, in September 11th, that was not a weather-driven event, but within hours after September 11th, the Air Force Weather Climatology Center, I spent some time with them there in Asheville. They were given a call immediately after. Can you conduct a study on winds in the affected areas? Obviously, when you have a disaster of that proportions, there's particulate matter in the air, there's fuel, there's vapors, there's fire, there's all kinds of things, and they wanted to know what's the impact of the winds and the local winds, and how are they prevailing and how are they going to change. And within hours, a study was conducted on winds at the Reagan National Airport, so that they could the decisions makers could decide what to do and where to position things to help limit the impact of the winds blowing these contaminants around. In fact, there was a New York National Guard weather unit was tasked to set up a system just like you see out here to the left. That's called a TMQ-53. One of those was positioned near ground zero in New York, so they could help monitor. You can imagine what urban winds are like, flowing around big buildings and downtowns, and you've got narrow alleyways and things, and they're trying to get an accurate assessment of what the winds are like, in fact, right at that location. And so we have a piece of equipment here that can go just about anywhere it needs to go, and it can monitor wind conditions, temperature, rainfall, the whole thing. Speaking of winds again, this is the Army artillery, in fact, takes weather pretty seriously, because you can imagine a big gun like the gun you see there, that's called an M777. It's a 155 millimeter artillery piece. It can shoot around about 25 miles away. So you can imagine how important it is. At 25 miles, that round traverses through, something tells me about, it goes up to 20,000 feet, and then it comes back down again. It goes a long ways, and all along the way it's influenced by, as you can imagine, the weather. So winds are very important to them. Well, in January 2002, the operations are fired up in Afghanistan, and the Charlie Battery of the 319th Airborne Field Artillery was deployed into Afghanistan, and typically an artillery unit has a weather detachment with them. And that weather detachment would launch weather balloons regularly so they could get an accurate assessment of the winds aloft. Well, what they discovered is they can use technology to their advantage. And at the Air Force Weather Agency, they have a program called iGrads, which uses numerical model output, satellite, available radio and SON data that is in the area. And they can produce point forecasts for upper level winds anywhere in the world. And this artillery unit said, we don't have to take our weather balloon guys, because we can just tap into the network, dial up this product for our location, and get a reasonably accurate indication of flight level winds that could impact those artillery rounds. And so that's what they did. They deployed without their weather guys. And so there you could see that the ability for weather technology to help out in this situation minimized how many people were actually put into harm's way. Special Operations, he's going to get up and talk a little bit more about their unit, but the Special Operators also have a history in impacting in weather. This was, so in March 2003, several months before the start of major military action in Iraq, Special Operations Forces were operating clandestinely throughout northern and central portions of Iraq. And there were two AFSOC Combat Weather Team airmen, Sergeants Dusty Lee and Dave Mack, were instrumental in providing critical weather support during this period. So what Sergeant Lee, he was in northeastern Iraq near the Iranian border for the purpose of conducting chemical downwind messaging. This is an important part of our support to the U.S. Army when they get on the ground and they're close to bad guys, and the bad guys might be using gas or things of that nature, even just smoke and other battlefield contaminants. The direction that winds are blowing is extremely important. And so they were issuing forecasts called chemical downwind messaging. In the event that chemical warfare was used against the U.S., and additionally, these are teams of a single weatherman with a team of other Army special operators, and he's gathering weather intelligence. You could imagine before the coalition forces flew in there, you know, they needed accurate assessment of what am I going to see on the ground. Is it going to be foggy? What kind of visibility am I going to be able to see my target? And to have an experienced operator like the STS guys on the ground providing that intelligence before our forces get there is vital.